Hello everyone. So in today's video we are going to be discussing about reverse osmosis. And to understand reverse osmosis we first need to understand what is osmosis. So osmosis is actually a movement of solvent molecules across a semi-permeable membrane from a solution of less concentration to the solution of high concentration, because water tends to balance both sides of the tank having different concentration. So if we are having solution A on the one side of the tank and solution B on the other side of the tank, and between them there is a membrane which could be permeable and which could be semi-permeable. And what is the difference between these two? If a membrane is permeable, it means it allows both solute and solvent molecules to pass across the membrane to balance the concentration gradient. Whereas if we talk about the semi-permeable membrane, in this case it allows only solvent molecules. So only the solvent molecules pass across the semi-permeable membrane. In this way they will balance the concentration gradient, whereas in permeable membrane both of them move across the membrane. So in the case of osmosis or reverse osmosis, semi-permeable membrane is being considered. So if we are having solution A with high concentration and solution B with low concentration, what will happen if there is semi-permeable membrane between them? The solution B, which is having low solute concentration, will move towards solution A having high concentration to balance the concentration gradient. So now we take an example of it, as if the solution A is having 5 mg of salt in 100 ml of water, which is more concentrated than solution B having 1 mg of salt in 100 ml of water. So obviously solution A is more concentrated and solution B will move towards solution A across the semi-permeable membrane to balance the concentration gradient. So reverse osmosis is actually reversal of this normal phenomena of osmosis. In osmosis and reverse osmosis, only semi-permeable membrane is being considered, which allows only solvent molecules to pass across the membrane. So normally in osmosis there is a movement of solvent molecules from low concentration of solute to high concentration of solute, but in reverse osmosis there is opposite of this case. So if we are having tap water on the one side of the tank and distilled water on the other side of the tank, and between them there is presence of a semi-permeable membrane. So as we know, semi-permeable membrane only allows solvent molecule to pass across it. So tap water, as we know, it is having more concentration of solute particles. So it is having salts, bacteria, pyrogens. So all of these things are making it more concentrated than that of distilled water, and distilled water is having much less quantity of salts and bacteria and pyrogen, which make it less concentrated. So as we have discussed previously that in normal osmosis process, a solution having low solute concentration will tend to move towards the solution having high solute concentration. So over here the solvent from distilled water will move towards the tap water section. In this way it will tend to balance the concentration gradient. As we know, anything other than solvent is actually making up this solute concentration. So tap water is having more concentration of solute, than that of distilled water. So what will happen, that distilled water, which is already in somewhat pure form, will also destroy its purity when it moves across the membrane and loses its solvent to the tap water. So now we can say that we do not need osmosis, but we need reverse osmosis, because we want to clean the tap water from all those salts, microbes and pyrogens, and we do not want to lose distilled water, because the process is actually destroying our already pure water. So what we need is, we need to reverse this process somehow, and how we do that is somewhat similar to the same mechanism as that of osmosis, but we just apply pressure over the tap water section. So now if we are having the same diagram again, over here we have tap water, and on the other side of tank we have distilled water, and between them there is semi-permeable membrane which allows only solvent molecules to move across it. So what will happen? In the reverse osmosis, we apply pressure. So when there is pressure being applied on the tap water section, what will happen? There will be movement of solvent molecules from tap water section to the distilled water section. So in this way, this is actually reversal of the normal osmosis process, in which we were having distilled water solvent moving towards the tap water. But over here we are actually separating out the solute particles of tap water from the solvent by applying pressure over the tap water. So solute particles which are present in tap water will left behind in that section, and pressure which is being applied is almost 200 to 400 pascal, and the semi-permeable membrane which is present between two sections should be able to bear this much pressure. So tolerability of the semi-permeable membrane is very much important, otherwise it will not tend to hold the pressure and it will destroy our process. So semi-permeable membrane could be of cellulose esters, it could be composed of polyamides which include nylon. Other than that, it can also be composed of polycarbonates. The water which is being obtained from this process is called as reverse osmosis water or RO water. So in other words, we can say RO is the process of forcing a solvent from a region of higher concentration and higher solute concentration through a semi-permeable membrane to a region of low solute concentration by applying pressure, that is almost 200 to 400 pascal. And this process is very efficient process. It almost retain all macromolecules over here, and in this way it filter out everything that is not required or not desired. So over here there is macromolecules which are left behind. Macromolecules include bacteria and pyrogen, and it also leave behind 85% of small ions such as sodium and chloride. So all of these are left behind over here, while solvent molecules which we need to be separated out are now over here. If this is not sufficient enough to remove all the impurities or all the things we require to separate from our solvent molecule, what we do is that we install several semi-permeable membranes in a series so that there will be more efficient process like this. Now if I have installed 3 semi-permeable membrane in one tank, so now when the pressure is being applied over the tap water, what will happen? There will be movement of solvent molecules across the membrane. But if small ions like sodium chloride, some percentage of these ions also cross that membrane, but there is presence of several other semi-permeable membrane in that tank, those ions will also have to pass through them, and in this way some of ion will stuck behind when they will have to pass through several series of those membranes. So in this way there is more chances of entrapment of those small ions. So in this way we are having much more pure water, and the process is actually very much efficient because of the installment of series of semi-permeable membrane which facilitate more removal of such small ions. As we know, macromolecules cannot pass through this membrane, but small percentage of these small ions can pass through them. So to avoid this or to remove those small ions up to approximately 99%, we have to install series of semi-permeable membrane which will allow more efficiency of the process, and we will have high grade RO water. So now we need to revise what is reverse osmosis. It is actually reversal of normal osmosis process in which there is movement of solvent molecules from a solution having low concentration to the solution having high concentration of solute molecules. So in reverse osmosis there is pressure being applied to the one side of the tank, and in this way what will happen, there will be pressure forcing the water or solvent molecules to move against the normal osmosis process, and in this way there will be movement of solvent molecules from higher solute concentration solution to the solution having low concentration of solutes. So in this way we will have pure water which is being required for several processes such as water for injection or other chemical processes. So this was all about reverse osmosis. If you have any question, let me know in the comment section below. And thank you for watching my videos.